So we've covered manually building an appliance, templates and pre-configuration for faster deployment and consistency, and the security and architecture, as well as the options built into the solution by way of firewall, IPS, IDS. Now, let's get into the true SD-WAN functionality. What makes SD-WAN so awesome? This topic is also pretty deep and wide, so we'll do our best to go through as much as possible. We'll first discuss BIOS, business intent overlays, and they are kind of the core of the solution. They are our source for how we handle traffic. We can choose several different options on how we want to handle our traffic. We can see that on the bio page here, the solution comes with 4 pre-built business intent overlays. These are very well built and honestly do a great job right out of the gate to properly handle our traffic. This is one of my favorite aspects of the SilverPeak solution. The fact that right out of the gate, I have a good starting point in my connectivity. I don't have to figure out all of this and build it from the ground up. So let's take a look at our options here. If I click on one of the BIOS, like real-time, I can start to see my options. First, what options do we have to get traffic into this bio? We can see that we can choose based on an ACL, overlay ACL, a specific LAN port, or an appliance-based ACL. In this case, the default is an overlay ACL, and if I click on the pencil to look at what is matching for this bio, we see a whole list of different audio and video providers, as well as anything coming in marked EF from a QoS perspective. In addition, at the bottom of the list is an actual application group of voice applications as well. There really isn't much missing here from a voice side solution. If you have Cisco telephony, Microsoft Teams, Ring Central, we're going to catch most everything given the applications and protocols listed here. So this is where and how we define what we want in the bio. Next, we can choose what type of topology we want for the bio. Do we want mesh, where every appliance creates tunnels to every other appliance? For voice between sites, this is probably the right thing to do. But if we take, for example, an application like Citrix, where servers might only exist in the data centers, maybe we want this hub and spoke, knowing we wouldn't really have any site-to-site traffic here. In my lab, I don't have any hub sites defined, but the architecture is pretty self-explanatory. If I choose hub and spoke, my appliances will only build tunnels to the hubs. Next, we get options on what interfaces we want to use to build the SD-WAN. I've modified this from the default, as my lab only uses Internet 1, Internet 2, and MPLS 1. They are primary for me for all sites, assuming they exist. Remember before, I keep saying labels build tunnels. This is that tie. When I apply a label to an interface in the deployment, it looks at what BIOS are applied to the appliance and how those are configured, and it builds these tunnels. Now, I have an option for backup as well. If I pull my LTE over to backup here, I can see now I get an additional box offering me an option of when to actually use the backup. Do I only use it if all of the above are down? Or do I use it if the above go dirty and don't meet my SLA? SLAs are over here on a per bio basis. I don't have them defined right now. 0% is essentially the equivalent of them being off. Now the other note here is the cross-connect option. We can have cross-connect groups. Based on this, we can see I have group 1 tied to INET 1 and INET 2. In this scenario, my tunnels would get built INET 1 to INET 1 at every other site, and INET 1 to INET 2 at every other site. If I were to set these to none, tunnels would only get built between labels that matched my site to another site. Moving on here, at the bottom we have our link bonding policy. We can see here the differences in how we handle traffic. HA is mission critical. We don't want to drop any traffic, even with packet loss, latency, jitter. We want instant failover. HQ is similar, only our failover is sub-second rather than instant. HT is still sub-second, but also uses load balancing. HE is also sub-second, so the bandwidth efficiency shown here is essentially how much FEC we're going to use for forward error correction. That doesn't mean I can only use 50% or 80% of the link. It simply means we're going to send more FEC to protect the traffic and prevent loss. Now, HA and HQ will also utilize both circuits. It's not that they don't do load balancing, but it's not traditional load balancing in that we can see here it is based on waterfall on overall quality. So if the bandwidth is there, we're going to use it. HT and HE use load balancing in the traditional sense. HT uses it based on link capacity. HE uses it based on link utilization. We also have the ability to choose a custom and set up what we want from this perspective. Over here on the right, we have our settings for QoS security and optimization. We can choose to enable boost, something we haven't talked a lot about, but equate it to WAN optimization, deduplication, acceleration on a per bio basis. For voice traffic, it probably would not make much sense to try to boost that traffic. It works very well with applications like CIFS and replication. Peer unavailable option. What do we do if our peer is down that we're trying to send to? What traffic class, from the shaper's perspective, are we putting this into? And what are we doing with traffic that comes in marked from the LAN and the WAN? We can either choose just to trust it and keep that marking, or we can, of course, remark it. Now, at the top here, we see there are two tabs to the bio. This one specifies SD-WAN traffic to internal subnets. What are internal subnets? If I click the pencil here, we can see these are the defaults. So essentially our RFC 1918 address space is considered internal. That is what will get applied with this setup. The other tab is our breakout to internet and cloud services. Here again, we get to choose which links to break out this traffic to. And you'll notice here I have excluded my MPLS simply because I know that I cannot send, in my case, internet traffic across the MPLS. I, of course, could advertise a default route and have it come over the MPLS and utilize this either in a backup scenario or as part of my primary scenario. On the left, we have our options as to what we're going to do with this traffic. Are we going to break it out locally? And in this scenario, if it's internet destined, that would essentially mean NATing it directly to the internet. Are we going to backhaul it via the overlay? That would be, of course, somewhat of a hub and spoke technology where we would be backhauling that internet traffic to a data center where it would get dropped out. Or we have options for Netscope. If I was to bring up the Zscaler integration, I would have a Zscaler logo over here as well, and a number of other SASE providers that we can obviously build and use to break out that traffic too. So in my case, this is set up as the default. Can I backhaul via overlay? No, not really. I'm not advertising a default route anywhere. So if this were to fail and it was to see this, it would of course not be able to do it anyway. It would fail. And at that point, my traffic is going to drop. So that kind of covers the makings of a bio or business intent overlay. We can see here again, as I stated, there are four built in. Critical apps, WebEx, Salesforce, a number of other applications, bulk apps. We get Dropbox, FTP, SFTP, replication, and then the default overlay is, of course, a match everything. This is our catch-all, if you will, and this is how we're handling it. This can all be modified. In addition, we can create new bios as well. Now, it's also important to note in how these are applied. If I click on Apply Overlays, I can see, because I've highlighted all of my appliances over here, I see them over here, and these are the overlays present. If I decide that I don't want real-time to be involved, I can apply that, and it will pull that real-time bio and tear down the tunnels that it created for those between the sites. I can also, of course, choose to do this in the configuration wizard as I go through. On the same page that I use to apply templates, I also choose which bios I would like to apply, that being here. All right, let's get into some fun stuff. Let's take a look at some of this in action. As you can tell, we didn't really make any modification to the system from stock. A few modifications to Orchestrator, but the core of the system is pretty much ready to go right out of the box. With slight modifications to meet your business need, it's a very simple setup. First, I switched my default overlay to high efficiency. So here we're using load balancing, but no path conditioning in the way of FEC. I also removed the cross-connect group. This really just for easier visibility into what's happening. I've fired up my Linux boxes at the west and south sites, and as we can tell, I have an iPerf test running between the two. I'm going to stop and restart this just so it doesn't time out on us. Now, we have a total of 17 meg of throughput to work with. If I look at my west site on the deployment tab, you will see we've got a 10 meg iNet1, a 7 meg iNet2, and a 3 meg MPLS. The south site does not have MPLS. It does have the 10 meg and the 7 meg internet. So, total of 17 meg throughput. I do, however, have 20 meg licenses. So, we know we should theoretically be able to get roughly 17 meg through between the two sites. So let's take a look at what's going on. If we go to the flows page here, we can see all of the flows for our environment. In this scenario, you can see all of the flows across all of the appliances. If I were to click just on the west appliance, here I would just see the flows as what's currently happening at the west site. In my environment here, you can see there's very few flows. I've got some DNS, every once in a while some NTP, and obviously we see here my iPerf flow. Most of any time spent troubleshooting with SilverPeak SD-WAN is likely going to lead you to this flow screen. I have a number of options to filter based on what I'm looking for in application groups, IP subnet, source dest, what port, zones, overlays, any of the flow characteristics. In addition, I can also look at flows that have ended in the past that aren't currently active. So here I'm looking at the last 5 minutes. I could go to the last 24 hours and see anything here in a lighter gray is a flow that ended. So If I was to receive a call saying, hey, this isn't working, when did you last try, I could go try to find that flow and see what was going on with it. So if we just look at the active flows here, let's take a look at what we get to see. Right? First, we get to see the uptime. How long has this flow been running? We see what overlay it's in and what overlay it's using. If we had integration with Aruba ClearPass, we would be able to see username data, etc. The protocol, the application, if it was detected, in our case it is iPerf, the two IPs and ports, the inbound and outbound bytes. In this case, we can see that I am sending data, and this is just return traffic, and then the inbound and outbound tunnels that it was sending to. So here I can tell that I'm looking at west, the appliance, the flows on west, and I'm sending to south via our default overlay. In addition to this, if I click on detail, I get a whole slew of data about this flow. Route information on how it was routed, what it did, QoS information, firewall data, security stats, and across the board, a whole list of information. In addition, I can pull up a chart for this flow, and what we'll see here is the live real-time throughput, inbound or outbound, for that flow. So over here we can see, here we are, roughly 17 meg on the WAN and the LAN in this scenario. So that validates to us that we are indeed using both of these links. If we want to get into more detail about what exactly is going on in that overlay as a whole, we have a whole bunch of different options to look under the monitoring tab at different client information, application information, tunnel information. In our case, I'm going to go to the tunnel live view, and in this scenario I will look at our west and our south. In this scenario, we already validated that our traffic is in the default overlay. So again, as it relates to SilverPeak West, I'm going to pull up the tunnel live view. And here we can see our traffic as well as the specific utilization of each interface. So total in the overlay, we're looking at just under 17 meg, iNet 2 just under 7, iNet 3 just under 10. Again, validated we are maxing out these links as it relates to their throughput. In this same screen, we can also look at the tunnel and interfaces based on loss, jitter, latency, and an MOS score. We can also look at the hops in between, where in my case we would see the internet hops between these appliances, and we get to choose which direction, inbound versus outbound. In my case right now I'm only concerned with the outbound, as I'm sending the data from from west to south. Now here, let's get rid of our bandwidth and let's just look at loss. We can see that since we started watching this live, we're not seeing any loss on any of these links. Now, if I come over to Eve, head over to my south site, edit the quality of this link, and throw in 3% loss. We come back over to Orchestrator, and within a second or two, we should pick up this loss. And there it is. So we notice down here, roughly 3% on average. However, up on our overlay, we're seeing a total of 1.5% to 2% up here. Now again, that's because we're not seeing any loss in the INET2 link, just the loss in the INET1 link. Let's go ahead and fix that quick. Clear up this link. And we should see this return to normal. There it did. So now let's take a look at what would happen if we change our business intent overlay to high throughput. Here, notice we're implementing path conditioning, so some FEC involved in managing packet loss. We're still load balancing paths. We'll apply that, and yet again we'll see up here we started that deployment, and now that that's deployed, let's go back and look at what happens. West, south. Here again, we should see we're still averaging roughly 17 mega throughput, 7 and 10. We'll take a look at the loss. I'm going to pause the video and let this go a little bit so we have more green to look at here. Alright, now let's jump back over and again introduce our loss. And come back and take a look at what happens. We can see our loss started, but notice now the default overlay. We took an initial hit and may take a little hit here and there, but we're no longer seeing the average 3% loss in the overlay. That is FEC making up for the difference. It is handling that loss at the far end. Let's go ahead and fix our issue here. Clean this up. And this should drop off. And we notice now our loss is cleared. So, again, let's go back, change our default overlay now to high availability. Notice, very similar, only in this scenario, we are indeed using more FEC. Save and apply that. We can see it kicked off. We'll wait for it to finish here. Now that that's finished, another thing I can do if I highlight both of these and come to the tunnel view, it will automatically put these in for me. So now, when we open this back up, we will see yet again we should be using roughly our 17 meg. And again, this isn't traditional load balancing like the original bio, but it is waterfall. It's flowing over additional data that it can use on that link, knowing full well that it's clean and working properly. So I've switched over to loss, and we can see, of course, the link is running clean. Now, again, we come back in, introduce our 3%, and watch what happens. In this case, we started seeing our loss on INET1 as expected, but we didn't see any loss in the default overlay as a whole. And again, that's FEC making up for the loss at the far end. The parity packets we're sending were enough to put all of the loss back together at the remote end. In this case, we're sending more parity, and yes, ultimately that would affect the bandwidth a little bit, but at the advantage of the additional protection. So in my case, we didn't really see any loss in bandwidth as a result. Obviously, this is the only flow I really have going, so we're not going to see that too much here. So this is an example of how these BIOS work, and really an awesome example of what SD-WAN does for you, as well as how it can take cheaper ISP links, even broadband, and make them no different than MPLS links. That pretty much covers this video. We went over the BIOS and what they do and how they're pretty much the core to the system, and how you can architect your environment to properly handle traffic as needed. This, I would say, is probably the most important piece to understand about the whole solution to make it really work for your environment.